Welcome to this presentation by the Stanford Crash Course Collective. Today we'll be examining the paper called VizWiz, Nearly Real-Time Answers to Visual Questions. In our life habits, we don't really recognize the extraordinary visual components of our environment and daily activities. Things that often go unnoticed by most people are a great source of frustration and loss of independence for those who suffer from impaired vision. What could possibly be done so that visually impaired people can overcome these difficulties and lead a fairly comfortable life? There have been various innovations in the past decade that have aimed at this very goal. One such innovation was the development of special-purpose devices such as barcode readers and light detectors. Another solution was the use of talking mobile devices, which were very expensive, too rigidly programmed, and could not evaluate their interpretation of texts. They were ineffective in interpreting common text such as graphic label and handwritten notes. Other applications like ESP Game and Solana intended to provide descriptions of images. They had high response times which were highly variable, and hiring multiple workers, or Turkers as AMT would call them, for such tasks was easily done with the Turkit library, using common programming paradigms so the answers could arrive faster. What could be better alternatives to this existing solution? And how about using a mobile application that is cheap and easy to use to solve it? The authors present VizWiz. Combining workers and automated tasks, VizWiz leverages Amazon Mechanical Turk workers to assist blind people with real-time solutions to their questions. VizWiz steps in to address the issue of inaccuracy. Instead of just relying on an automatic approach, VizWiz recruits remotely located human workers to answer questions in nearly real time. With real people answering questions, blind users can receive feedback and receive answers that are directly relevant to their queries, rather than getting an automated response. The aim is to assist blind individuals in the same way their sighted friends would, by providing feedback on simple everyday problems. The authors took a step in understanding how blind people might want to use a system such as VizWiz. So they surveyed 11 people about how they would use VizWiz. The subjects wanted to read text in a variety of situations: road signs, cafe menu boards, tags on clothes, and cooking instructions on packaged meals. Several participants wanted information about their physical appearance. For instance, how does this outfit look? Or is this shirt stained or discolored? Many participants just wanted feedback on how good the picture they took was, or other general information about them. To use the service, the user submits an image and a recorded question that is converted to text using a speech recognition service. VizWiz intelligently assigns workers from Amazon Mechanical Turk to manually answer the question, providing rapid responses to the user as soon as they are available.
To ensure that users receive answers to their questions quickly, the authors created a system for intelligently recruiting workers on Amazon Mechanical Turk. QuickTurk ensures that workers are available as soon as a question is posted and guarantees several high-quality answers to each user-submitted question. QuickTurk also optimizes the jobs posted to Amazon Mechanical Turk to make them easier to find for potential workers. When a worker is recruited using QuickTurk, they are brought to the VizWiz website and are presented with a user-submitted question to answer. By presenting the question on the VizWiz website instead of using the Amazon Mechanical Turk interface, the answers can be sent to users before the worker completes an entire job. As soon as a worker completes a question, they are presented with a new one, up to 3 questions per job. This helps to maintain worker engagement, which in turn leads to a larger worker pool and faster question answering time. Instead of waiting for questions to arrive, QuickTurk begins looking for workers while the user is still preparing the question. These workers remain engaged while they are waiting for new questions to arrive, which reduces response time. Using this technique, it becomes possible to maintain a pool of 10 or more workers. However, the cost of doing so could be prohibitive. QuickTurk uses several strategies to optimize worker recruitment through Amazon Mechanical Turk. First, QuickTurk posts more jobs than it actually requires. While not all of them will be completed by workers, this helps VizWiz stay atop the search results for workers. QuickTurk also posts jobs in batches and varies the titles and rewards to cover more search terms and improve visibility. These optimizations further help VizWiz to maintain an active worker pool that can answer user-submitted questions quickly and accurately. In this paper, the authors chose to limit QuickTurk to 64 times more jobs than were needed, posting a maximum of 4 jobs every 10 seconds. QuickTurk also used 2 different titles and 3 different rewards when posting these jobs. The authors gave 11 blind smartphone users the opportunity to try VizWiz and conducted a survey to determine how effective the service would be in a real-life scenario. All users were between the ages of 22 and 55, with 3 being female and the remaining 8 being male. Users were recruited remotely and were trained over the phone, at which point they were asked to use the app at least once a day per week. They were then asked to leave a spoken comment about their experience after each answer they received. Of the 82 questions asked, 80.9% were submitted using a photo rather than using speech recognition. The authors found that the topics of questions varied significantly, including color identification, reading text, and identifying objects. 9 of the images were too dark and 17 were too blurry for the question to be answered. Although a few other questions could not be answered due to other reasons, dark and blurry photos made the question unanswerable most of the times. This paved the way for the second iteration of the VizWiz prototype that helped alert users about such problems before sending questions to workers.
Overall, the first answer received was correct in 71 of 82 cases, where correctness was defined as either being an exact answer to the question or an accurate description of why the worker could not answer the question with the information contained within the photo provided. A correct answer was received in almost all cases by the third reply. The slide contains a histogram of the 122 workers who answered at least 5 queries based on the mean time they required per question. It is necessary to note that response time varied greatly depending on how the question was asked, photo versus speech recognition. Here we can see the time taken to receive answers under different conditions. The x-axis represents the number of questions in each category. The height of the white bar measures the average response time in seconds, and the thin bar expresses the range of variation of the response time. The most common problems were that the photos were either too dark or too blurry. For dark photos, we can create a grayscale histogram to check for any large concentrations of dark pixels indicating insufficient lighting, and for blurry images, we can compute the mean and standard deviation of an image from its binary map and evaluating these values using a set of pre-built covariance matrices. Overall, combining AMT workers along with the automation of system was found to be economical and effective. This system is also viable moving forward. Quick Turkate can already scale using the mechanical Turk in terms of responses per hour by raising the number of tasks per hit or by increasing the reward. Since participants knew that humans were answering their questions, they often built a requirement for human intelligence into their queries. The mTurk workers are also able to provide feedback on how images can be improved, so the future interaction between users and the app is smoother. While VizWiz is more oriented to answer a variety of questions, VizWiz Located focuses on answering questions that relate to locating objects in any environment. Its operation combines the VizWiz approach with automatic computer vision. A user first takes an overview picture and asks a localization question. A remote worker outlines the target object. Located uses this information then to orient the user to move towards the object. Once the user is close to the object, Located uses computer vision to help the user filter and identify the object. Optionally, the user can ask additional questions about the object. VizWiz development represents a new model of assistive technology in which human workers assist blind people in nearly real time. The first obvious direction that may signal the future work is to reduce time latency for audio. Secondly, cost reduction through the addition of new services. And third is purely technological. They are all open and fertile fields. The post-development survey led to the following conclusions. The answers were provided in almost real time to the users. 80% of the total participants were ready to pay the $5 premium. And people would love to get push notifications when the questions had been answered. The authors would like to end this presentation by saying that VizWiz is a great example of how technology can help visually impaired, and the authors hope that more research in this space will be extremely impactful and change the life of millions around the world.